What would you feel if you looked into the night sky and discovered that a giant piece of the universe was missing? Not a small dark cloud, not a gap between a few stars, not an ordinary patch of blackness between galaxies, but a vast cosmic region so empty that, on the scale of the universe, it almost feels like someone carved a silent wound into space itself. Imagine a sphere hundreds of millions of light-years wide, a region so huge that entire galaxy clusters could fit inside it, and yet when astronomers looked there, they found almost nothing. Not nothing in the simple human sense, because space is never truly empty, but almost nothing compared with what the universe usually provides. This is the Boötes Void, one of the strangest and most haunting emptinesses ever mapped by science. And the deeper one looks into it, the more disturbing the question becomes: how can a universe born from the Big Bang, filled with matter, dark matter, radiation, gravity and time, produce a place so empty that it seems as if galaxies never learned how to exist there? Before entering this darkness, pause for a moment and think about something strange. The universe is not evenly sprinkled with galaxies like salt on a table. It is woven. It is stretched into glowing threads. It is arranged like a cosmic web, with galaxies flowing along enormous filaments, gathering into clusters, forming walls, knots, bridges, and rivers of light. Between those glowing structures are voids, immense cavities where very few galaxies live. So yes, voids are real, and science expects them. But the Boötes Void is not just any void. It is so large and so underpopulated that when it was first recognized, astronomers were shocked. In a normal region of space of similar size, one might expect thousands of galaxies. In the Boötes Void, only a small number have been found compared with that expectation. That does not mean the void is magically impossible, but it does mean it pushes the mind to the edge of what ordinary intuition can accept. And here is the first twist. The terrifying thing about the Boötes Void is not that it is completely empty. The terrifying thing is that it is not completely empty. If it contained absolutely nothing, scientists could perhaps imagine some dramatic mistake in measurement, some observational blind spot, some illusion of mapping. But instead, a few galaxies do exist inside it, scattered like lonely islands in an ocean so vast that each one seems abandoned by the rest of creation. These galaxies are real. They shine. They contain stars, gas, dust, gravity, possibly planets, possibly moons, possibly worlds with skies. But around them, there is a silence so large that if the Milky Way were located deep inside such a region, our view of the cosmos might have been psychologically different. We may not have seen nearby bright galaxies as easily. Our ancestors might have imagined a far lonelier universe. Astronomy itself might have developed with a different emotional rhythm. So before we go deeper into this cosmic emptiness, take one quiet breath and stay with this mystery until the end. Because the Boötes Void is not just an empty region in the constellation Boötes, it is a question written across space. What does emptiness reveal about creation? If you love these strange scientific journeys through the deep universe, then like this video, subscribe to the channel and share your thoughts in the comments as we drift into one of the most unsettling places ever discovered. Because tonight, we are not traveling to a star or a planet or a black hole. We're traveling into absence itself. We're entering a place where the universe seems to whisper, not with light, but with silence. To understand why the Boötes Void feels so impossible, we must first understand what the universe looks like on very large scales. When we look close to home, space seems full of objects. The sun, the planets, moons, asteroids, comets, stars, nebulae, star clusters, and galaxies. But zoom out far enough beyond individual galaxies and clusters, and the universe changes personality. It becomes a pattern. It becomes structure. Galaxies are pulled by gravity into long filaments that stretch across hundreds of millions of light years. These filaments meet at nodes where massive galaxy clusters live. Between them lie broad, underdense regions called cosmic voids. This structure is called the cosmic web, and it is one of the most beautiful results of gravity acting over billions of years. It tells us that the universe is not chaotic in a simple way. It has architecture. This architecture began as tiny irregularities in the early universe. Shortly after the Big Bang, matter was almost evenly spread out, but not perfectly. There were regions that were very slightly denser than average, and regions that were very slightly less dense than average. These differences were incredibly small, but gravity is patient. Over billions of years, denser regions pulled in more matter, became even denser, and eventually grew into galaxies and clusters. Less dense regions lost matter to their surroundings and became emptier. This is how voids formed. They are not holes punched into space after the fact. They are regions that began with slightly less material and then became more empty as gravity moved matter away from them into the cosmic web. But here is where the Boötes Void becomes strange. Normal voids are expected. Simulations of the universe produce many voids. The cosmic web naturally creates empty spaces between its filaments. Yet the Boötes Void is enormous. Its commonly cited diameter is roughly a few hundred million light-years, often described around 250 to 330 million light-years across, depending on how its boundary is defined. That is not a distance the human mind can comfortably hold. Light, travelling at about 300,000 kilometers per second, would need hundreds of millions of years to cross it. A beam of light entering one side when early mammals were still small and hidden beneath dinosaurs might only now be emerging from the other side. That is not an empty room. That is not a desert. That is a cosmic silence measured in geological and evolutionary ages. The Boötes Void was identified in the early 1980s through redshift surveys, when astronomers began mapping galaxies not just by direction in the sky but by distance. Redshift is one of astronomy's greatest tools. Because the universe is expanding, light from distant galaxies is stretched toward longer, redder wavelengths. By measuring that stretching, astronomers can estimate how far away a galaxy is, at least on cosmological scales. When researchers mapped galaxies in the direction of the constellation Boötes, they noticed a remarkable absence. A vast region that should have contained many galaxies seemed nearly empty. It was like drawing a map of a crowded city and finding a neighborhood the size of a country with only a few lights on. At first, this emptiness was difficult to believe. Astronomy has a long history of observational traps. Maybe galaxies were too faint to be detected, maybe dust obscured them, maybe the survey missed certain types of galaxies, maybe distances had been misread. But as more observations came in, the basic mystery remained. There really was a huge underdense region. Later surveys found more galaxies inside it than the earlier studies knew about, but not enough to erase the void. The Boötes Void remained a striking cosmic feature, not an illusion, not a simple error, not an empty myth. It was real enough to force a serious question. How did the universe make a place like this? To feel the scale, imagine the Milky Way and Andromeda. They are separated by about 2.5 million light-years. That already sounds unimaginably far. Now imagine a region over 100 times wider than that separation, with very few major galaxies inside. The Milky Way belongs to the local group, a small collection of galaxies. The local group sits near larger structures, including the Virgo cluster and the Laniakea supercluster. We live in a universe where galaxies are not isolated in the deepest sense. They are connected by gravity, motion, and history. But a galaxy inside the Boötes Void may be profoundly isolated. It may drift through space with far fewer neighbors, fewer gravitational encounters, fewer mergers, fewer bright companions in its sky. That isolation matters because galaxies grow partly by interaction. In dense regions, galaxies pass near one another, pull on one another, distort one another, exchange gas, merge, ignite bursts of star formation, and transform their shapes. A spiral galaxy can become disturbed, small galaxies can be swallowed, gas can be compressed, producing new stars. In voids, evolution can be quieter. Galaxies may develop slowly, with fewer dramatic encounters. They may preserve features that would be disrupted elsewhere. They may be smaller, bluer, gas-rich, and actively forming stars in ways shaped by their lonely environment. So the Boötes Void is not only a question about emptiness, it is also a natural laboratory for asking how environment shapes galaxies. But then the deeper twist appears. If galaxies inside the void are so isolated, where did they come from? Did they form there from small pockets of matter that remained? Did they drift in from the edges? Are they arranged along faint internal filaments, like ghostly threads inside a larger emptiness? Observations suggest that even voids are not perfectly featureless. They can contain faint structures, thin galaxy chains, dwarf systems, gas, and dark matter. A void is not a pure vacuum. It is an underdense cosmic environment. The Boötes Void may be less like a perfect bubble of nothing and more like a vast low-density basin with a few delicate internal streams of matter. Still, compared with the rich cosmic web around it, it is astonishingly empty. The phrase, "it shouldn't be possible," must be handled carefully. In real science, the Boötes Void does not literally violate physics. It does not prove that cosmology is broken. It does not require aliens, magic, or a cosmic explosion that erased galaxies. What it does is challenge the imagination and test the statistical expectations of structure formation. The standard cosmological model, often called lambda cold dark matter or lambda CDM, describes a universe dominated by dark energy, dark matter, and ordinary matter. It successfully explains many large-scale observations, including the cosmic microwave background, galaxy clustering, and the general web-like structure of the universe. Within this model, voids naturally arise. Large voids arise too, but extremely large, extremely empty regions are rare, and rarity is where mystery begins. A rare thing is not impossible, but when humans encounter something rare enough, the mind reacts as if reality has made a mistake. Think of a desert with no footprints for 1,000 kilometers. Think of an ocean with no islands for a distance wider than continents. Think of a forest where one enormous circular region contains almost no trees. You might not say nature is broken, but you would ask what history created that pattern. The Boötes Void invites the same question. Was it born from an unusually deep underdensity in the early universe? Was it created by the merging of smaller voids? Did surrounding superclusters pull matter away so efficiently that this region became unusually empty? Or is our map still incomplete, hiding faint galaxies below the limits of detection? One of the most reasonable explanations is that the Boötes Void may have formed from the merger of smaller voids. In the cosmic web, voids can grow and connect. As matter flows out of underdense regions toward denser filaments, neighboring voids may expand into one another, creating a larger emptiness. If several smaller voids merged over billions of years, the result could be one giant region with only a few galaxies left inside, perhaps arranged where old boundaries once met. This idea is elegant because it does not require exotic physics. It simply extends normal cosmic evolution. But even then, the size and emptiness remain awe-inspiring. It means gravity did not merely build the bright structures of the universe, it also sculpted the darkness between them. Another key player is dark matter. Dark matter does not shine, absorb, or reflect light in ordinary ways, but its gravity shapes galaxies and large-scale structure. In the early universe, dark matter began clumping before ordinary matter could freely collapse into galaxies. It formed invisible scaffolding. Ordinary matter fell into dark matter wells, and galaxies formed where enough matter gathered. So when we ask why the Boötes Void is empty of galaxies, we are also asking whether it is empty of dark matter. A true absence of dark matter would help explain the lack of galaxies. But voids are not necessarily dark matter free. They simply have less dark matter than average. Their dark matter may be spread thinly, insufficient to form many large galaxies. This is one of the quiet secrets of cosmic emptiness. Emptiness has gravity too, but less of it. A void is not a place where gravity disappears. It is a place where gravity is weaker compared with surrounding dense regions. Matter inside tends to be pulled outward toward the walls and filaments around the void. Over time, this can make the void emptier and the surrounding cosmic web richer. The void expands relative to the denser regions, not because it is pushing like an explosion, but because matter drains away from it. It is like a valley inverted in density. Instead of matter falling into the void, matter escapes from it toward gravitational ridges outside. Dark energy adds another layer. The universe is expanding, and that expansion is accelerating on large scales. Dark energy does not create voids in the simple sense, but voids can be especially affected by cosmic expansion because they contain less matter to slow local expansion through gravity. In underdense regions, expansion can dominate more easily. Over immense time, voids may become larger and more pronounced while dense regions remain gravitationally bound. So the future universe may become even more void-dominated. Galaxy groups and clusters may stay together, but the spaces between them will stretch into greater isolation. The Boötes Void, then, may not be an exception to cosmic destiny. It may be a preview of the universe's long, lonely future. Now imagine standing on a planet inside a galaxy near the center of the Boötes Void. The planet has oceans, mountains, perhaps clouds, perhaps living beings who look upward at night. Their own galaxy would fill their sky with stars, just as the Milky Way fills ours. But beyond the local stars, the deep universe would seem poorer. With fewer nearby galaxies, fewer bright external structures, fewer close cosmic neighbors, the night might feel more self-contained. The civilization there, if it existed, might still eventually discover the expansion of the universe and the cosmic microwave background. But the emotional first impression of the cosmos could be different. They might not see a nearby Andromeda-like galaxy with the same ease. They might feel that their galaxy is almost alone. There is something profound here. Our understanding of the universe depends partly on where we are located. We are not at the center of creation, but we are not in the emptiest known region either. We live in a relatively ordinary cosmic neighborhood, rich enough to reveal other galaxies, not so dense that the sky is dominated by nearby clusters, not so empty that the universe looks barren. From our position, the cosmic web can be inferred and mapped. But from a deep void galaxy, cosmology might have taken longer to develop. The evidence would still exist, but some clues would be fainter. This reminds us that science is universal, but the path towards science can be shaped by environment. The Boötes Void also teaches us that nothing is one of the most complicated words in physics. On Earth, nothing usually means absence. No object, no sound, no person, no movement. In space, nothing becomes stranger. A region may contain almost no galaxies, but it still contains particles, radiation, dark matter, magnetic fields, neutrinos, and the stretching fabric of space-time. Even intergalactic space is not perfectly empty. There may be thin gas, perhaps only a few atoms per cubic meter or less, depending on location. There is the cosmic microwave background passing through it, ancient light from when the universe became transparent. There are gravitational fields from distant structures. There are quantum fields everywhere. The Boötes Void is empty only compared with the galaxy-rich web, not empty in the absolute philosophical sense. And yet comparison is exactly what makes it shocking. The universe has an average density. On small scales, density varies wildly. Stars are dense, planets are dense, nebulae are thin, intergalactic space is thinner. But on very large scales, cosmologists expect the universe to become statistically homogeneous, meaning that if you average over large enough volumes, things should look roughly similar in all directions. This is part of the cosmological principle. The Boötes Void does not necessarily break that principle, because structures of hundreds of millions of light years can exist within a universe that becomes homogeneous on even larger scales. But it sits near the emotional boundary where the human mind asks, how large can a structure be before it starts to challenge our assumption that the universe is broadly smooth? This question matters because cosmology is a science of averages and exceptions. The cosmic microwave background is extremely uniform, but its tiny temperature fluctuations seeded all later structure. Galaxy surveys show a web, but also statistical patterns. Voids are part of those patterns. If a void is too large, too empty, or too common, it might suggest that our model needs adjustment. If it is rare but allowed, it becomes dramatic confirmation of how powerful gravity and time can be. The Boötes Void is therefore not merely an object, it is a test. It asks whether our simulations can produce similar features. It asks whether survey biases mislead us. It asks whether dark matter and dark energy, as currently understood, are enough. Computer simulations are essential here. Cosmologists create virtual universes using the laws of gravity, initial conditions from the early universe, dark matter behavior, gas physics, and cosmic expansion. These simulations show matter collapsing into filaments and clusters while voids expand. They produce a cosmic web that looks remarkably like what we observe. Large voids appear naturally. Some simulations can produce very large underdense regions, especially when one considers the enormous volume of the observable universe. In a universe this large, rare things will occur somewhere. The real question is not simply, can a big void exist? The real question is, how often should a void like Boötes appear, and does its observed emptiness match expectation? That is where caution becomes important. Popular descriptions often make the Boötes Void sound like a cosmic impossibility, as if scientists found a forbidden hole in reality. The truth is more subtle and more beautiful. It is not forbidden. It is unusual. It is extreme. It is a natural structure that lives at the edge of expectation. and this is what makes it scientifically powerful. In science, anomalies do not always destroy theories. Sometimes they refine them. Sometimes they reveal missing details. Sometimes they force better measurements. Sometimes they simply remind us that the universe is larger and more varied than our instincts assume. There is another twist. The Boötes Void may look emptier, partly because galaxies inside it are difficult to detect. Bright galaxies are easier to find. Faint dwarf galaxies, low-surface brightness galaxies, and diffuse gas-rich systems can hide from surveys, especially at large distances. A void that appears nearly empty may contain many dim systems below the threshold of older instruments. Over time, better surveys have found more galaxies in and around cosmic voids. This does not erase the void, but it softens the idea of absolute emptiness. The Boötes Void might be underpopulated by bright galaxies while still hosting faint structures that earlier surveys missed. But that softening does not remove the wonder. In fact, it adds another layer of mystery. If faint galaxies exist inside the void, then they are precious witnesses. They may preserve clues about how galaxies form when the universe provides little material and few interactions. They may reveal whether star formation in voids is delayed, suppressed, or simply different. They may show how dark matter halos grow in underdense environments. They may help answer whether void galaxies are younger on average or merely less disturbed. Every faint galaxy inside the Boötes Void is like a message in a bottle from a quieter version of cosmic history. The galaxies found inside large voids often challenge simple expectations. One might imagine that an isolated galaxy would be dead, starved of fuel and dim. But some void galaxies can be gas-rich and star-forming. Because they experience fewer mergers and less environmental stripping, they may retain gas longer. In dense clusters, galaxies can lose gas through interactions with hot intracluster medium or gravitational harassment. In voids, galaxies can evolve more gently. So emptiness does not always mean inactivity. Sometimes emptiness preserves. Sometimes the quietest environments allow slow fires to keep burning. The Boötes Void also asks us to think about time. When astronomers look at distant galaxies, they look into the past because light takes time to travel. The Boötes Void is hundreds of millions of light years away, so we see it as it was hundreds of millions of years ago. On cosmic timescales, that is not extremely ancient, but it is not present either. The void we map is a delayed image. Its galaxies have continued evolving since the light left them. Its boundaries have shifted. Its internal structures may have changed. The universe never presents itself all at once. Every map of deep space is a map of time layered with distance. This means the Boötes Void is not a frozen hole. It is dynamic. Matter moves. Galaxies drift. Structures grow. Voids expand relative to denser regions. The cosmic web evolves. If we could watch the universe in fast-forward over billions of years, we would see matter streaming out of voids, filaments sharpening, clusters growing, and empty regions swelling like dark bubbles between luminous threads. The Boötes Void would not appear as a static absence, but as a slow cosmic exhalation. It would be the universe breathing matter away from a region that began slightly poorer and became profoundly quiet. Why did that region begin poorer? The answer leads back to the earliest moments we can study. The cosmic microwave background, released about 380,000 years after the Big Bang, shows tiny variations in temperature and density. These variations are believed to arise from quantum fluctuations stretched to cosmic scales during inflation, a hypothesized extremely rapid expansion in the very early universe. Those fluctuations became the seeds of all later structure. Regions slightly denser became the ancestors of clusters. Regions slightly underdense became the ancestors of voids. In that sense, the Boötes Void may be the amplified memory of a tiny primordial whisper. A microscopic irregularity stretched by cosmic inflation and magnified by gravity over billions of years may now appear as a silence hundreds of millions of light years wide. This is one of the most astonishing thoughts in cosmology. The largest structures in the universe may have roots in quantum uncertainty. The emptiness between galaxies may trace back to the restless behavior of fields in the infant universe. A void is not merely a lack. It is fossil history. It is a region where the early universe had slightly less matter, and time turned that slight difference into an immense dark basin. The Boötes Void is therefore not just empty space. It is a monument to the sensitivity of cosmic evolution. A tiny beginning became a giant outcome. Still, the Boötes Void feels too clean, too huge, too eerie. This is why people sometimes reach for exotic ideas. Could it be the scar of a collision between bubble universes? Could it be related to unusual inflation physics? Could it indicate non-standard dark matter behavior? Could an ancient cosmic event have cleared matter from a region? These ideas can be fascinating, but they must be handled with scientific discipline. There is no accepted evidence that the Boötes Void was created by aliens, a universe collision, or any dramatic destructive event. The conservative explanation remains structure formation through gravity in an initially uneven universe. But science keeps curiosity alive by asking whether extreme structures might contain hints of deeper physics. The beauty of a mystery is not in abandoning evidence. The beauty is in following evidence into stranger and stranger places without letting imagination outrun truth. The Boötes Void is powerful because it does not need fantasy to be astonishing. Its real scale is enough. Its real emptiness is enough. Its real place in cosmic structure is enough. It shows that the universe can create loneliness on a scale that almost defeats language. It shows that absence can be as meaningful as presence. It shows that the dark spaces between galaxies are not blank background, but active parts of cosmic history. Consider the name itself, Boötes. It comes from a northern constellation often associated with a herdsman or ploughman in ancient sky traditions. Humans named patterns of nearby stars long before we knew that beyond those stars lay galaxies, clusters, filaments, and voids. The Boötes Void is not inside the constellation in a physical sense. Constellations are directions on the sky, not true cosmic containers. But the name gives this vast emptiness a human handle. It reminds us that our ancient sky stories now overlap with modern cosmic cartography. Where our ancestors saw a figure among stars, astronomers later found a tremendous absence behind them. This creates a strange poetic contrast. A constellation is made by connecting points of light. A void is discovered by noticing where the points are missing. Both are patterns made by human minds looking upward, but one comes from imagination and the other comes from measurement. One is a myth drawn across the nearby stars. The other is a real underdensity in the distant universe. Together they show how astronomy has evolved from storytelling to mapping, and yet the wonder remains the same. We are still creatures staring into darkness and asking what it means. The Boötes Void is sometimes compared to bubbles in foam. Imagine soap foam, where thin walls of liquid surround empty pockets of air. In the universe, galaxies outline the walls and filaments, while voids are the pockets. But the analogy is imperfect because cosmic voids are not empty of space-time, and galaxies are not painted on a surface. The universe is three-dimensional, and its web is complex. Still, the foam image helps. If the cosmic web is foam, then the Boötes Void is one of the larger bubbles, a swelling cavity in the luminous structure. The question is why this bubble became so large. In foam, large bubbles can form when smaller bubbles merge. That same idea may apply cosmologically. Smaller underdense regions may have expanded and combined, leaving behind a larger void. If galaxies remain inside, they may trace the leftover boundaries between those older voids. This would explain why the Boötes Void is not perfectly empty, and why its internal galaxies might have some arrangement rather than being randomly scattered. The void may be a graveyard of smaller voids, a place where several emptinesses became one larger emptiness. That is a twist worthy of the universe. Even nothingness can merge. But a void does not need to be perfectly spherical. The Boötes Void is often described with a rough size, but its actual shape is not a smooth cosmic ball with clean edges. Cosmic structures are irregular. Boundaries depend on definitions, survey limits, and density thresholds. Where exactly does a void end? At what density does emptiness become normal space again? These are not always simple questions. A void is identified statistically. It is a region with fewer galaxies than average. Its edge may be a gradual transition into filaments and walls rather than a hard border. So when we say the Boötes Void is hundreds of millions of light years across, we are simplifying a complex three-dimensional underdensity. This matters because public imagination often turns the void into a perfect black sphere, like a hole cut from the universe. Real cosmic voids are messier and more interesting. They have internal substructure. They have galaxies, gas, dark matter, and boundaries that blur into the web. Their emptiness is relational. They are defined by what is missing compared with what should statistically be there. The Boötes Void is not a literal hole in space-time. It is not a black hole. It is not sucking matter in. It is almost the opposite, a region from which matter has largely moved away. A black hole is dense beyond imagination. A void is under-dense beyond intuition. A black hole traps light because gravity is extreme. A void lets light pass through almost undisturbed because there is so little matter. A black hole is a collapsed object. A void is an expanded absence, and yet both capture human fear because both challenge ordinary experience. One says too much matter can break our sense of space and time. The other says too little matter can create a silence so vast that it feels unreal. The Boötes Void also connects to the question of cosmic fate. As the universe expands, distant galaxies recede from us. In the very far future, if dark energy continues to drive accelerated expansion, galaxies outside our gravitationally bound local group will disappear beyond our cosmic horizon. Future observers, if any exist in the merged remnant of the Milky Way and Andromeda, may see a much emptier universe. The evidence of the Big Bang may become harder to detect. The cosmic web beyond the local bound structure may fade from view. In that sense, the future universe may look like a void from almost anywhere. The Boötes Void is not only a place, it is a preview of cosmic isolation. This gives the void a melancholic beauty. It is not violent, it is not explosive, it is not bright, it is quiet. It teaches through absence. The universe is often celebrated for its lights: stars, nebulae, galaxies, supernovae, quasars. But the dark spaces are equally important. Without voids, there would be no web-like contrast. Without underdense regions, matter would not be arranged in the same grand architecture. Emptiness gives shape to abundance. Silence gives meaning to the song. The fact that we can detect the Boötes Void at all is a triumph of human measurement. No astronaut has travelled there. No probe has entered it. We know it through light, redshift, statistics, telescopes, and patient mapping. Astronomers gather spectra from galaxies, determine distances, plot positions, and build three-dimensional maps. Each galaxy becomes a point. Enough points reveal patterns, enough absence reveals voids. It is one of the most elegant forms of discovery. Not finding an object, but finding a missing population. There is a deep lesson here about science. Sometimes the most important discovery is not what appears in the data, but what fails to appear. A missing signal can reveal a planet. A missing particle track can reveal a neutrino. A missing galaxy population can reveal a void. The Boötes Void was discovered because astronomers noticed that the universe was not giving them what it normally gives. They listened to the silence in the data. That is a scientific act as profound as seeing a new star. Now think of the galaxies within the void as survivors. They exist where few others do. They may have formed from rare density peaks inside a broad underdensity. They may live in small dark matter halos that manage to gather enough gas. They may be separated by distances far larger than galaxies in richer regions. Their histories may be quieter, but not empty. Stars still ignite. Massive stars still die. Elements still form. Planets may still gather from dusty disks. Comets may still fall towards suns. Chemistry may still unfold. Even in a void, the universe can create complexity. This is another twist. Cosmic emptiness does not mean cosmic meaninglessness. A single galaxy inside a void may contain hundreds of billions of stars. A single star may have planets. A single planet may have oceans. A single ocean may have life. From the outside, the Boötes Void appears nearly empty. From within one of its galaxies, existence could still be rich beyond imagination. Scale changes everything. At one scale, emptiness dominates. At another, stars blaze. At another, atoms dance. At another, minds ask questions. The universe is not one story. It is layers of story nested inside one another. When scientists say a void is underdense, they are speaking mathematically. But when a human hears it, the phrase becomes emotional. Underdense means fewer galaxies, less matter, weaker clustering. But it also means isolation, quiet, distance, and ancient history. Science gives us the measurement, imagination gives us the feeling, A good cosmic documentary needs both. We must not invent false facts, but we must allow real facts to become vivid, and the real facts of the Boötes Void are vivid enough to feel almost fictional. Let us return to the beginning of the universe again, because the answer to the void may lie there. The early universe was hot, dense, and expanding. Matter and radiation were tightly coupled. Sound waves move through the primordial plasma, creating patterns called baryon acoustic oscillations. Dark matter, less affected by radiation pressure, helped shape gravitational wells. When the universe cooled enough for electrons and protons to form neutral hydrogen, light escaped, creating the cosmic microwave background. Matter then began collapsing more efficiently into the structures we observe today. In this story, voids are not accidents. They are part of the same process that made galaxies possible. This is important. The same universe that made the Milky Way made the Boötes Void. The same laws that formed stars also formed emptiness. Gravity does not only pull matter together. By pulling matter together in some places, it leaves other places behind. Creation and absence are linked. Every cluster is fed partly by matter that did not remain in voids. Every filament is a boundary between emptier regions. The cosmic web is a balance of concentration and evacuation. The Boötes Void is one of the grandest examples of evacuation on the cosmic map. Could the Boötes Void contain hidden dark galaxies, objects with dark matter and gas but few stars? This is an interesting possibility in general void studies. Some dark matter halos may fail to form many stars if they are too small, too warm, or deprived of gas. Such halos would be difficult to detect directly. They might reveal themselves through gravitational effects or faint hydrogen emission. If many such objects exist, the void may be less empty in mass than it appears in starlight. But that would also deepen the mystery because it would mean the void is not lacking all structure, only luminous structure. It would remind us that astronomy sees what light allows, while the universe contains much more than light reveals. Neutral hydrogen surveys can help because hydrogen gas emits radio waves at a wavelength of 21 centimeters. This emission can reveal gas-rich galaxies that optical surveys may miss. Low-surface brightness galaxies can also hide in plain sight because their light is spread thinly across a large area. Modern and future surveys can improve the sensors of void galaxies. The more we find, the more accurately we can say how empty the Boötes Void truly is. Science does not stop at the first dramatic number. It keeps measuring. Even so, the original shock remains historically important. When astronomers first found such a large region with so few galaxies, it helped change how people thought about large-scale structure. The universe was not merely clusters scattered through space. It had huge connected patterns and huge empty regions. Redshift surveys transformed cosmology by turning the sky into a three-dimensional map. They revealed that galaxies trace structures larger than anyone once imagined. The Boötes Void became one of the symbols of that transformation, a discovery made not by seeing a bright object, but by mapping the absence between bright objects. Now let the mind drift across the void itself. Suppose a photon leaves a galaxy on one side and travels toward the other side. For hundreds of millions of years, it crosses a region with very few major gravitational interruptions. It passes through faint gas, through dark matter fields, through ancient microwave background photons, through expanding space. Civilizations could rise and fall in galaxies elsewhere while that photon is still crossing the emptiness. Stars could be born, live, and die. On Earth, continents could shift, species could evolve, and human beings could eventually build telescopes. The photon keeps moving. The void is so large that crossing it becomes a history of worlds. This scale changes the meaning of distance. On Earth, distance is measured by walking, driving, flying. In the solar system, distance is measured by light minutes and light hours. Between stars, light years become necessary. Between galaxies, millions of light years become ordinary. But a void hundreds of millions of light years across forces the mind into a different kind of silence. It is no longer a distance one can imagine traveling. It is a distance one can only surrender to. The Boötes Void is not large like a mountain. It is large like time. There is also a subtle observational effect called the integrated Sachs-Wolf effect, where cosmic microwave background photons can gain or lose tiny amounts of energy, passing through evolving gravitational potentials, including large voids and superclusters, in a universe with dark energy. Very large voids can leave subtle imprints on the cosmic microwave background. The Boötes Void itself is not usually the most famous example in that discussion, but cosmic voids in general are important for understanding how large-scale structure interacts with ancient light. This shows again that voids are not passive nothingness. They can affect radiation, statistics, and the way we test cosmological models. Voids also matter for measuring the expansion of the universe. Because they are underdense, their internal dynamics differ from denser regions. Some cosmological tests use void shapes, void distributions, and galaxy flows around voids to study dark energy and gravity. If gravity behaves differently on large scales than general relativity predicts, voids may help reveal it. Why? Because voids are simpler in some ways than clusters. Clusters involve complex baryonic physics, hot gas, mergers, and dense non-linear interactions. Voids are emptier, cleaner gravitational environments, making them useful laboratories for subtle effects. The Boötes Void, then, is not only a mystery, it is a tool. A tool made of emptiness is a beautiful scientific irony. Telescopes usually collect light, but cosmologists also collect absence. They measure where galaxies are not. They study the shape of underdensity. They use emptiness to test gravity, dark energy, and cosmic history. In the Boötes Void, the lack of galaxies becomes information. The silence becomes data. The emotional power of the Boötes Void comes partly from the human fear of being alone. We look at the universe and hope for connection. Stars connected into galaxies, galaxies into groups, groups into clusters, clusters into superclusters. The cosmic web satisfies that hope. It shows that the universe is connected on immense scales. But voids remind us that connection is incomplete. There are vast separations. There are regions where the web thins almost to vanishing. The universe is not a crowded city everywhere. Some of it is a wilderness beyond wilderness. Yet without wilderness, the cosmos would not have its current shape. The Boötes Void exists because matter elsewhere gathered. It is the negative space of the cosmic masterpiece. In art, negative space is the empty area around the subject, and it shapes how the subject is seen. In cosmology, voids are negative space on the larger scales. They define the filaments. They outline the clusters. They reveal the distribution of matter by contrast. If the universe were all galaxies with no voids, its structure would be less readable. Emptiness makes the web visible. Could there be voids larger than Boötes? Yes, depending on definitions and surveys, astronomers have identified many large voids and supervoid candidates across the observable universe. Some are associated with large underdensities that may span hundreds of millions, or even more than 1 billion light-years in certain measurements. But comparing void sizes is not simple, because different methods define boundaries differently. Some structures called supervoids are elongated or composed of multiple connected underdense regions. The Boötes Void remains famous because it was one of the earliest and most striking large voids identified, and because its emptiness captured scientific and public imagination. The fact that even larger underdensities may exist does not make Boötes less mysterious. It places it in a broader family of cosmic absences. The universe may contain many great voids, each with its own history. Some may be more elongated, some more spherical, some emptier, some filled with faint galaxies, some connected in chains. Mapping them is like mapping an invisible continent made of low density rather than land. The more we survey, the more detailed the dark geography becomes. Future surveys are crucial. Missions and observatories designed to map large numbers of galaxies can refine our understanding of voids. The Euclid Space Telescope, the Vera C. Rubin Observatory, the Dark Energy Spectroscopic Instrument, and other projects contribute to a richer view of cosmic structure. They can help locate faint galaxies, measure weak gravitational lensing, study dark matter distribution, and constrain dark energy. With better data, the Boötes Void may become less of a vague emptiness and more of a detailed cosmic ecosystem. The mystery may not disappear, but it will become sharper. This is how science often works. First, a mystery appears as a shadow. Then instruments improve and the shadow gains texture. What looked like nothing becomes a complex landscape. The Boötes Void began as an astonishing absence. Over time, it becomes a region with measurable galaxies, possible substructures, density profiles, environmental effects, and cosmological significance. The emotional phrase, "so empty it shouldn't be possible," evolves into a scientific question. What initial conditions and gravitational evolution produce this degree of underdensity, and how well does it match our model? But the phrase still has power because human intuition is not built for cosmic statistics. We are built for forests, rivers, faces, storms, hunger, danger, and home. We do not naturally understand a sphere hundreds of millions of light years across with only a sparse scattering of galaxies. We call it impossible because our minds evolved in a world where empty spaces are small compared with landscapes. The universe operates on scales where emptiness can be larger than anything humans can physically experience. The Boötes Void is not impossible to physics, it is impossible to instinct. This distinction is important for realistic storytelling. The void should not be presented as a violation of the Big Bang model. It should be presented as a dramatic edge case within the cosmic web, a structure that pushes expectation and invites deeper study. The most honest wonder is not, science has no answer. The most honest wonder is science has partial answers, and those answers reveal an even deeper beauty. We know voids form from underdensities. We know gravity moves matter into filaments. We know dark matter shapes the scaffolding. We know cosmic expansion influences the growth of voids. But the exact details of any one enormous void remain complex. The Boötes Void also reveals the limits of visual imagination. If one could fly through it, there might be long stretches where nothing dramatic happens. No glowing nebulae, no nearby galaxy rising like a giant spiral, no dense clusters sparkling in every direction. A cinematic version might show a black tunnel, but reality would be subtler. Space would look black because space almost always looks black. Stars would still exist if one were inside a galaxy, but between galaxies, the emptiness would not announce itself with walls or borders. You would know you were in the void only by measuring the absence of neighbours across enormous distances. This makes voids philosophically unsettling. They are not dramatic to the eye in a simple way, they are dramatic to the mind. A black hole can be imagined as a dark sphere with an accretion disk. A nebula can be shown with colour. A galaxy can be photographed. A void is harder. It is a statistical structure. It becomes visible only through maps. It is an intellectual object. To appreciate it, one must think in 3 dimensions, in averages, in redshifts, in millions of light years. The Boötes Void is a mystery that requires the mind to become a telescope. And when the mind becomes a telescope, a strange truth appears. The universe is mostly empty. Not just the Boötes Void, but everything. Atoms are mostly empty space. The solar system is mostly empty space. Galaxies are mostly empty space between stars. Clusters are mostly empty space between galaxies. The cosmic web itself contains vast voids. Emptiness repeats at every scale, but not always with the same meaning. Inside atoms, emptiness is governed by quantum fields and probabilities. Between planets, emptiness is orbital space. Between galaxies, emptiness is cosmological structure. The Boötes Void is one grand expression of a universal theme. Reality is built from small concentrations separated by enormous absence. Yet those concentrations matter intensely. A star is a concentration of gas where gravity ignites fusion. A planet is a concentration of rock, metal, ice, or gas where chemistry can become complex. A galaxy is a concentration of stars and dark matter. A cluster is a concentration of galaxies. Life, as far as we know, depends on concentration. Atoms close enough to react, molecules stable enough to store information, energy gradients strong enough to drive change. Voids remind us that complexity is local. The universe as a whole may be vast and cold, but within small islands of density, extraordinary things happen. This creates a powerful contrast for the script of existence. The universe is not uniformly alive with activity. It is mostly silence with rare fires. It is mostly darkness with islands of light. It is mostly emptiness with pockets of chemistry, memory, and maybe consciousness. The Boötes Void magnifies this contrast until it becomes almost spiritual. It shows the background against which stars matter. It shows how precious density is. It shows how rare the conditions for complexity may feel when viewed from the larger scales. But one must be careful. Voids do not necessarily mean life is less likely in the universe overall. Galaxies inside voids may still form stars and planets. The question of life depends on many factors: metallicity, star formation history, planetary stability, radiation environment, and time. Void galaxies might have fewer dangerous nearby supernova or fewer disruptive encounters, but they might also have different chemical enrichment histories. We do not know enough to make grand claims. What we can say is that a void galaxy would live in a different cosmic environment. An environment shapes possibilities. There is another fascinating idea. Because galaxies in voids are more isolated, they may have fewer mergers, meaning their disks can remain undisturbed for longer. A stable galactic environment could be favourable in some ways. On the other hand, fewer interactions might mean fewer triggered starbursts and a different pace of chemical enrichment. The universe rarely gives simple answers. Emptiness can be both limiting and protective. Isolation can be both lonely and stable. The Boötes Void becomes a cosmic experiment in what happens when galaxies grow without the crowd. This experiment has implications for understanding our own galaxy. The Milky Way did not evolve in a total void. It has absorbed smaller galaxies. It interacts gravitationally with the local group. It will eventually merge with Andromeda. Our galaxy's history is shaped by environment. By comparing galaxies in different environments, astronomers can separate what is universal from what is local. Void galaxies help answer, what does a galaxy do when left mostly alone? Cluster galaxies answer, what does a galaxy do under pressure, crowding, stripping, and collision? Together they tell a fuller story. So the Boötes Void is not just a cosmic oddity. It is part of a larger scientific method. Compare extremes. To understand temperature, study both fire and ice. To understand gravity, study both dense clusters and empty voids. To understand galaxy evolution, study both crowded cities and lonely deserts. The universe teaches through contrast. Now let us imagine the boundary of the Boötes Void. At the edges, galaxies become more common. Filaments and walls rise like luminous shores around a dark ocean. Matter that did not remain in the void gathered there. If one could map the gravitational flow, one might see galaxies and gas subtly moving toward denser structures. The void is not isolated from the cosmic web. It is defined by the web around it. Its emptiness is framed by abundance. The edge is where silence becomes song again. This boundary may be one of the most important parts of the void. Voids are not separate objects floating in space. They are cells in the cosmic web. Their walls contain galaxies, groups, and filaments. The interiors are underdense. The boundaries show how matter transitioned from one regime to another. Studying the edge can reveal how galaxies respond to changing density. It can show whether star formation, morphology, and gas content vary gradually from void center to wall. The Boötes Void, if mapped in detail, is not just an empty center. It is a gradient of cosmic environment. Gradients are often where science becomes interesting. A sharp category like empty or full is easier to imagine, but reality often works through transitions. A galaxy near the void edge may experience different influences than one deep inside. A small group inside the void may follow a faint filament. A dwarf galaxy may be nearly invisible. A bright galaxy may mark a rare density peak. The void is a landscape of probabilities. Its emptiness is not uniform nothingness, but structured scarcity. The phrase structured scarcity may be one of the best ways to understand the Boötes Void. It is scarce in galaxies but not structureless. It is low in density but not absolute vacuum. It is rare but not supernatural. It is explainable but not boring. And this balance between explanation and awe is the heart of modern cosmology. The universe is more magnificent when we understand more, not less. Knowing that the Boötes Void formed through primordial fluctuations, dark matter scaffolding, gravitational evacuation, and cosmic expansion does not make it smaller. It makes it deeper. Think of a single tiny fluctuation in the early universe. At first it is almost nothing, a slight difference in density. No stars exist yet, no galaxies, no planets, no eyes, just hot plasma, dark matter, radiation, expanding space, and tiny variations. Billions of years pass. Gravity amplifies the variations. Matter drains from some regions and gathers in others. Stars ignite, galaxies bloom, clusters form, and where the fluctuation was underdense, a void opens. Eventually, intelligent beings on a small planet around an ordinary star build instruments and notice that one region of the distant universe is strangely empty. The beginning and the observer are connected by time. This is why the Boötes Void is not merely out there, it is part of our story too. We are made of matter that gathered, not matter that escaped into emptiness. We live in a galaxy that formed in a region dense enough to create stars and elements. Our bodies are possible because the universe was not perfectly smooth. If the early universe had been exactly uniform, there would be no galaxies, no stars, no planets, no life. The same unevenness that made the Boötes Void also made us. We are children of cosmic imbalance. That thought changes the emotional meaning of emptiness. The void is not a mistake. It is one side of the same process that made existence complex. The universe needed differences. It needed slightly denser and slightly less dense regions. From those differences came structure. From structure came stars. From stars came elements. From elements came planets. From planets came chemistry. From chemistry, perhaps, came minds. The Boötes Void is a vast underdense chapter in the story that also produced consciousness. Yet there is still something haunting about looking at a map and seeing such a large blank. Maps are supposed to reassure us. They turn the unknown into shape. But some maps reveal unknowns more strongly. The map of the Boötes Void says, "Here is a place where the universe did less of what you expected. Here is a region where the cosmic web thinned dramatically. Here is a silence so large that it had to be named." Naming a void is itself strange. We usually name things: mountains, rivers, stars, planets, galaxies. But a void is named for what is missing. It is a named absence. That is philosophically powerful. The Boötes Void has identity because galaxies are not there in the expected numbers. It is a landmark made of scarcity. It proves that absence can be a feature, not merely a lack of features. In human life, emptiness often feels negative. Empty rooms, empty roads, empty hands, empty silence. But in the universe, emptiness is generative. It shapes motion. It defines structure. It provides contrast. It allows expansion. It preserves ancient clues. The Boötes Void teaches a more mature idea of emptiness. Not failure, but form. Could the Boötes Void be related to the distribution of superclusters around it? Very likely, in the broad sense that voids and superclusters are mutually defined. Dense structures around an underdense region can gravitationally pull matter outward from the void. Large-scale flows may evacuate matter over time. The surrounding cosmic web is not just a border, it is part of the void's formation history. To understand the void, one must understand its neighborhood. Emptiness is never alone. It is produced in relation to density. This is true even in everyday life. A valley exists because mountains surround it. A shadow exists because light is blocked. Silence is noticed because sound is possible. The Boötes Void exists because the universe elsewhere is luminous and clustered. Its emptiness is meaningful because the cosmos is not empty everywhere. The observation that only a relatively small number of galaxies were initially found inside the Boötes Void gave rise to famous comparisons. Some descriptions say that if the Milky Way were in the center of the void, we might not have known other galaxies existed until much later in astronomical history. This is a poetic exaggeration in some forms, because sufficiently advanced telescopes could still detect distant galaxies, but the underlying point is valid. Nearby bright galaxy counts would be lower, and the cosmic neighborhood would feel far more isolated. The psychological discovery of the universe might have been delayed or altered. Imagine early astronomers on such a planet. They map stars in their own galaxy. They see nebulae, clusters, perhaps some faint external smudges far away. But the sky lacks obvious nearby galactic companions. The idea of countless galaxies beyond their own may be harder to reach. Their philosophers might debate whether their galaxy is the main island of existence. Their first deep surveys might produce shock when extremely distant galaxies finally appear beyond a vast local emptiness. Their version of Edwin Hubble's discovery could feel even more dramatic. They might learn the universe is huge not through abundance nearby, but through the delayed revelation of distant structure. This shows that location can influence cosmic humility. We learned that the Milky Way is one galaxy among many, partly because other galaxies are visible and relatively accessible to observation. In a deep void, the same truth would remain, but the evidence might be more subtle. The universe would not change, but the journey to understanding it might. There is something almost literary in that possibility. A civilization born in a void might develop a cosmology of loneliness before discovering the cosmic web. A civilization born in a dense cluster might see galaxies everywhere and develop a cosmology of abundance. We, somewhere between extremes, discovered both. Enough nearby galaxies to reveal multiplicity, enough dark sky to sense vastness. Our cosmic address shaped our wonder. The Boötes Void also has a role in public imagination because it resembles a forbidden blank on the map. Humans are drawn to forbidden blanks. Ancient maps had unknown oceans. Early telescopic maps had dark lunar Maria. Planetary maps had canals imagined on Mars. Modern cosmic maps have voids. The difference is that the Boötes Void is real, but its mystery does not require monsters. It is not frightening because something hides there. It is frightening because almost nothing does. That is a rare kind of fear. Most fears are about presence, a predator, a storm, a disease, a threat. The fear of the void is about absence. It asks what happens when the universe removes context, neighbors, landmarks, and crowdedness. It is the fear of scale without comfort, and yet once understood scientifically that fear becomes awe. The void is not hostile, it is simply vast. A common misconception must be corrected. The Boötes Void is not dangerous to us. It is far away, and it is not expanding toward us like a destructive bubble. It is not a vacuum that sucks galaxies in. It is not a cosmic monster. It is a region of low galaxy density. Its significance is intellectual, not immediate. It threatens our assumptions, not our planet. That makes it the perfect object for deep science storytelling. It is safe, distant, and still profoundly unsettling. The distance also means we are seeing a chapter of cosmic history. The light from galaxies around and inside the void left hundreds of millions of years ago. When we map them, we are mapping the past. Meanwhile, the universe has continued expanding. The void has continued evolving. The true present state of that region is inaccessible to us right now, because information cannot travel faster than light. Every cosmic map is a compromise with time. The Boötes Void we discuss is both a place and a historical image. This time delay adds a meditative layer. The universe never gives us instant truth at large distances. It gives us memory. A star in the sky is a memory. A galaxy is a memory. A void is a memory of missing galaxies. The Boötes Void is a memory of ancient underdensity preserved in light. We are not only looking across space, we are listening to an old silence. What would happen to the Boötes Void in the far future? If dark energy remains similar to what it is now, voids will continue becoming more dominant in volume. Bound structures like galaxies and clusters will remain, but unbound structures will drift apart. Voids will effectively grow as the cosmic web becomes increasingly isolated into islands. The universe will become darker for future observers. Star formation will eventually decline as gas is consumed. The great age of galaxies will fade. In that future, the Boötes Void may not seem exceptional. It may seem like an early hint of what most of the universe was becoming. This makes the void prophetic. It is not just a relic of the past, it is a symbol of the future. The universe began hot, dense, and nearly uniform. It became structured, luminous, and web-like. It may end, on the largest scales, increasingly cold, dark, and isolated. The Boötes Void sits in the middle of this story as a region where isolation has already become extreme. It is a future-like place in the present universe. But there is also hope inside this vastness. Even in underdense regions, galaxies form. Even in galaxies, stars form. Even around stars, planets may form. The universe does not need to be crowded everywhere to create wonders. It only needs enough local density in enough places. A void can be enormous and still contain islands of possibility. This is a powerful emotional result. Emptiness does not erase creation. It frames it. Scientific humility is essential here. We do not know every galaxy in the Boötes Void. We do not know every faint structure. We do not know the full dark matter distribution in perfect detail. We do not know whether future surveys will revise its emptiness upward or downward. But we do know enough to say it is a genuine large underdensity and a remarkable feature of the cosmic web. We know enough to study it seriously. We know enough to be amazed without exaggerating beyond evidence. The difference between mystery and misinformation is discipline. Mystery says, here is what we know, and here is what remains unclear. Misinformation says, because something is unclear, anything is possible. The Boötes Void deserves better than that. Its real science is richer than any false claim. The truth already contains darkness, scale, ancient history, dark matter, cosmic expansion, and unanswered questions. It does not need fake impossibilities. So when the title says the Boötes Void is so empty it shouldn't be possible, the deepest meaning is this: it should not be possible according to ordinary human expectation. It feels too large, too silent, too underpopulated. But physics is not governed by human expectation. Physics is governed by initial conditions, gravity, expansion, dark matter, and time. The void is possible because the universe is stranger than instinct. It is possible because small early differences became enormous late structures. It is possible because gravity builds by emptying as well as gathering, and that realization is more amazing than a violation of science would be. A violation would simply break the story. But the real explanation expands the story. It shows how one set of laws can create both crowded galaxy clusters and enormous voids. It shows how the universe can be coherent and surprising at the same time. It shows how a model can be successful while still leaving room for extreme, beautiful, unsettling features. Let us now travel mentally through the cosmic web toward Boötes. We pass through regions where galaxies gather in groups. We cross filaments where matter streams like luminous rivers. We see clusters shining with thousands of galaxies immersed in hot gas and dark matter. Then the density begins to fall. The bright points become fewer. The gravitational cities are behind us. Ahead is a broad region where the map thins. We enter the void not through a wall, but through a fading. The universe does not announce the boundary. It simply becomes less populated. Deeper inside, distances between major galaxies grow enormous. A galaxy appears, then nothing comparable for a long stretch. Another galaxy, faint and isolated. Perhaps a small group. Perhaps a thin chain. But mostly the surrounding volume remains quiet. The cosmic microwave background passes through. Dark matter lies thinly spread. Space expands. Time moves. The void is not dramatic moment by moment, but its totality is overwhelming. It is a silence that only becomes visible when measured across hundreds of millions of light years. This is why the Boötes Void is perfect for a sleep documentary. It is not a place of sudden explosions, but of deep, slow wonder. It invites the mind to drift. It turns cosmic structure into meditation. It asks us to think about absence without panic. It lets us feel small, not in a humiliating way, but in a truthful way. To know that such emptiness exists is to understand that the universe is not designed around human comfort, and yet human minds can still understand it. That is extraordinary. There is a quiet victory in that. We are tiny beings on a small planet, orbiting a normal star, inside one galaxy among many. Our bodies are fragile, our lives are brief. Yet through mathematics and instruments, we can map a void hundreds of millions of light years wide. We can identify patterns in galaxy distribution. We can infer dark matter. We can connect early universe fluctuations to present-day structure. We can name an absence in the direction of Boötes and ask how it came to be. That ability is one of the universe's most surprising products. Maybe the deepest twist is that the universe created beings capable of noticing its emptiness. Matter gathered into stars, stars forged elements, elements formed planets, planets developed chemistry, chemistry developed life, and life built telescopes to discover where matter did not gather. We are concentrations of the universe studying its absences. We are islands of density contemplating the void. The Boötes Void, then, is not merely out there. It reflects something about knowledge itself. Knowledge often grows at boundaries, between light and dark, known and unknown, presence and absence. The void is a boundary object. It marks the boundary of expectation. It forces astronomers to ask whether their maps are complete, whether their simulations are accurate, whether their assumptions are too simple. It turns emptiness into inquiry. As surveys improve, we may find that the Boötes Void contains more galaxies than once believed. We may map its internal filaments. We may understand its formation as a merger of smaller voids. We may show that it fits comfortably within lambda CDM statistics, or we may find subtle tensions that help refine cosmology. Either outcome is valuable. If it fits, it confirms the power of our model. If it strains the model, it teaches us where to improve. Science wins by listening carefully, and the void continues to wait. It is not aware of our questions. It does not glow brighter because we named it. It does not become less empty because we fear it. It simply exists as a vast underdense region in the cosmic web, shaped by billions of years of evolution. Human drama happens around it, but the void itself is calm. This calmness is part of its grandeur. It is a cosmic fact beyond urgency. In the final understanding, the Boötes Void is not a mistake in the universe. It is a masterpiece of absence. It is what happens when gravity, dark matter, primordial fluctuations, and expansion collaborate for billions of years to move matter elsewhere. It is an enormous low-density basin, surrounded by the brighter architecture of the cosmic web. It contains some galaxies, but far fewer than ordinary regions. It is not impossible, but it is extreme enough to make the word impossible feel emotionally correct. And perhaps that is the best way to end this journey. The Boötes Void should not exist according to the small imagination we inherit from everyday life, but it does exist according to the grand imagination of physics. It is a reminder that the universe does not merely contain objects, it contains patterns. It contains not only light, but the spaces where light rarely gathers. It contains crowded clusters and lonely galaxies, shining filaments and immense dark basins. It contains enough structure to create us and enough emptiness to humble us. So the next time you look at the night sky, remember that between the stars and beyond the galaxies, there are regions so vast and quiet that they feel like pauses in creation. Somewhere in the direction of Boötes, far beyond the familiar stars of our sky, there is a cosmic emptiness hundreds of millions of light years wide. It is not truly nothing. It is history. It is structure. It is a fossil of the early universe. It is a laboratory for dark matter, galaxy formation, and cosmic expansion. It is a warning against trusting human intuition too much. And it is a beautiful proof that even absence can have a story. The Boötes Void is so empty that it feels impossible, yet it is real. And in that truth lies the greatest result of all. The universe is not only stranger than our imagination, it is stranger in ways that can be measured, mapped, studied, and slowly understood. The void does not destroy science. It invites science deeper. It does not end the story of the cosmos. It opens a quieter chapter. And in that quiet chapter, written not in stars but in the missing spaces between them, the universe tells us that emptiness itself can be one of its most powerful creations. End.